Okay, so finishing this question, it was r of the ladder, m of the ladder, g, and that's going to be plus the r of the person, and it told us in the question that she was 1.8 meters out from the edge, so that's her r, 1.8 meters. Told us she was 87 kilograms times 9.81 meters per second squared. And how far is the Fn2 from Fn1? It's the whole distance. It's 4.1 meters. Okay, and so Fn2, the one that's on the, I called 2 the one that was furthest away from the person, that should end up equaling 392.352 newtons. The question, though, asked for both of them. So to find the second one, you have a couple of choices. You could pick your pivot point at Fn2 and do exactly the same thing, but I think easier would probably just be do the sum of the forces in the y direction, because it's not moving in the y. So it'll be Fn1 plus Fn2 minus Fg of the person minus Fg of the ladder equals 0. And so you're looking for Fn1, so it'll be m of the person g plus m of the ladder g minus the Fn2 you just found. So Fn1 will equal, the mass of the person was 87 kilograms, 9.81 meters per second squared, plus the mass of the ladder was 3.6 kilograms times 9.81 meters per second squared, minus this 392.352 newtons we just found. And when you do that, you get an Fn1 of 496.4339 newtons. So Fn1 is bigger than Fn2. If you pause and think about that for a second, it should make sense, because the person's closer to Fn1. So Fn1's taking more of the overall weight than Fn2. Okay, so that's number 27. I also asked you to try number 28. So number 28 is some kind of a crane. So it has an arm going out like this. So it's like that hanging sign question, the hanging sign questions that you've done. This angle is 32 degrees. What's different is that the container isn't all the way out on the end. It's part way in. So it says a crane with a movable pulley system and a horizontal arm is moving a large container. The mass of the container is 355 kilograms. It's hanging from a cable that's 6.5 meters out on a 7.5 meter long arm. So the whole thing is 7.5 meters, but the container is only 6.15 meters out. The arm has a mass, so the mass of the beam itself is 345 kilograms. So the container is 355 and the arm is 345. And the angle is 32 degrees. And the first part wants to know what's the tension in the cable. There is going to be a force here, but for right now we're going to pick our pivot point there, and so we can avoid it. So do sum of the torques, and it should equal 0. So the torque from the force at where the arm is connected, the torque from the, whoops, it's a uniform arm, so better put in our Fg of the arm here, and this is our Fg of the container. So a torque from tension, a torque from the weight of the arm, a torque from the weight of the container. This one's going to go to 0. The tension's going to cause it to rotate counterclockwise, positive, these two clockwise, negative. R tension, F tension, sine theta tension, minus R of the arm, Fg of the arm, sine theta of the arm, minus R of the container, Fg of the container, sine theta of the container. These two angles are 90. So these sine thetas will go to 1. you're solving for ft. Its theta is not 90, it's 32. So take the other two terms over, they become positive. R of the arm, M of the arm, G, plus R of the container, M of the container, G, divided by R tension, sine theta tension. Fill in your numbers. R of the arm, it said it was a 7.5 uniform arm, so the R should be half that, 3.75. Mass of the arm was 345 kilograms, 9.81 meters per second squared. R of the container, it said it was 6.15 meters out. Mass of the container, 355 kilograms, and 9.81 meters per second squared. And then that's going to get divided by R of tension. It's all the way out, so 7.5 meters, and the angle was 32 degrees. Punch this into your calculator, and you should get 8582. 8582.28 newtons. Okay, so that's part A. Part B wants to know what force does the vertical part of the crane exert on the boom. So it's looking for this F. And so again, we should do sum in the X and sum in the Y to get it, just like we did for other hanging sign questions. So in the X direction, there's going to be an X direction, an Fx of this fella minus the tension X. And that'll equal 0, so this Fx should be Ft, and the tension's X will be cosine. So it'll be that 8582.28 newtons